Okay, Bismillah ar-Rahman ar-Rahim. So this is the test bench that we wrote for the GCD uh, last in one of the last videos. Okay, um, most of the things are going to be the same. Okay, we do not need for the comprehensive test bench. The waveform is only for debugging, so we do not need it actually. Um, so I'm going to copy portions of the comprehensive test bench that we made for the 2-to-1 multiplexer from before. This is the one. So first of all, you can see that we are opening the file names. I need to change the names here. And then error counter, we need to copy that as well. Yeah, I will copy everything and then change as I need in the suspension. Of course, there is a lot of change that need to be done because the circuit here, the circuit in the multiplexer was combinational, whereas the circuit here in the GCD calculator is sequential. So there will be definitely some changes in the applying the inputs. Okay, so files, I think it was GCD, yeah. This one GCD, and let's go GCD. And error counts is fine. Okay, so now this is no longer binary, it's decimal, and we are reading only two values, which are, let's call them yeah, DN1 and DN2, exactly. DN1, DN1, and DN2. Was it? Or 0 and 1? No, 1 and 2. Okay. And no need for S here. And then I'm going to read the expected GCD. Let me change that. What was it defined as in the it was defined as an integer basically, or yeah. No, actually it's the same type as the output. Yeah, the same type as the output, which means that it should be a register, and expected, I'm going to call it expected GCD, yeah? And copy that. So I'm changing this to expected GCD. So I just read basically the data N1 and data N2 and the expected GCD. So I just can't wait for 10 time units here and expect the result to be there for me. No, this is a sequential circuit. It needs operation here. Okay, I need to operate with the go and other signals here. So reset and go, and the clock as well. Okay, so I need to set my. This is irrelevant from all the code. So I need to set my clock to 0, for example. And I want to reset my circuit to 1 at the beginning, and then I mean it's exactly the same logic that we did before. Okay, same logic that we did before, exactly. Okay, so and then we wait for the positive edge of the clock. So, but we don't need to apply DN1 or DN2. All right. Now, at the positive edge of the clock, if you remember, we are going to go based on go. to either S0 or S1. In this case, we are going to go to S1 because go is 0. Okay. So basically here, what I need to do is nothing to be done here, okay? But during the loop here, need to, where is that? So, yeah. So basically, I need to give go at the negative edge of clock. I have to give go a 1, okay? And this ensures the positive edge on go, the positive edge on go. Okay, so basically, let me just add, for the sake of making sure, let me add a negative edge here. I'm just waiting for the negative edge here, and then of the clock, of course, and then entering the loop here. Okay. So at the negative edge of the clock, I'm going to apply a positive edge on go. So now I know my algorithm will work, and I don't need to wait for 10 actually time units. I need to wait for the positive edge on what was the signal name? Data ready, was it? Data ready. Yeah, data ready. On data ready. Data ready. Once data ready gets a positive edge, then I know my data, which is what? Which is D out, yeah? D out. D out. If D out does not equal expected GCD, then I'm in trouble. So I have to record that as an error and increment the error count. I'm going to also write decimal here as my inputs, and also decimal for both both of the expected and I mean golden output, as well as the output that we got. Oh, this is DN1 and DN2 and expected GCD, and this is D out. Okay. Now this is what, okay, so this is the while loop. Once you get out of this while loop, you know that you have actually, all right. So yeah, I think we need to do one more thing here, which is basically at after we check the equality and update the errors, we can actually negative edge. What is negative edge of the clock? Okay, at the negative edge of the clock, just for so here I'm going to also set go to be 0 here. Okay, I know that even if go is 0 and I go back according to my logic, so let me just share again the picture, okay, the ASM chart. Even if go is 0, okay, and I even if I set go to 0 and I go back to actually S1 in this case, because we changed the logic, remember? Even if that's the case, my ready is going to be 1 for the duration of the time in which go is 0. So it is not going to change until I change go to 1 and get a positive edge on go, so that now ready is going to be reset to 0 to take the next data inputs. Okay. Coming back to this, so go is 0 just to ensure that we are going to actually start the restart the algorithm to the right state. Okay. So after coming back, so in the first loop here, we are going to apply the N1 and the N2, and go is going to be 1 exactly here. And then the calculation of the GCD will actually start here exactly at the positive edge that follows this negative edge. Okay. And then it will actually conclude with the positive edge of D ready. Okay. Once D ready is asserted high, positive edge on D ready, we set go to 0 to go to state S1 rather than S0. And then if you continue here, you can see that, do I need this? Let me see if I need it or not. So if I continue here, I'm going to read another DN1 and DN2, and then set my go to 1 again. Okay, meaning that this is a positive edge. Okay, and then wait for D ready again to crunch the GCDs. Okay, GCD calculator. Yeah, I think this is cool. Maybe we need to add one more negative edge here to for synchronization, but I think this should work fine. Okay, this should work fine. The rest actually is not required. Yeah, and just comment it out. So this is the comprehensive test bench for the GCD. Okay, can go ahead and compile it so that you guys see. So iVerilog. By the way, iVerilog is the Icarus Verilog compiler, and it's, by the way, open source and free, so you can download it and install it on Windows or Mac or whatever environment that you have, even Linux. Okay, so yeah, so I have my GCD.v and my TB GCD.v. Okay, lots of errors. Good, cool. Let's try to debug now. Could not find variable input file. Okay, that's simple. Okay, you can just, yeah, these are actually required. Okay, these are the file descriptors. I forgot to include here in the bench. Do I need all of them? Input file, I know I need. Output file, I need. In the file, and R, as well as error counts. Yeah, all of them are actually needed. Yeah, R and error count. Yeah. All right. Let's see. Clear again. And okay, no errors. Okay. So now my my executable is in a.out on the simulation output. Okay, let me just run it. You know, there is something wrong. I know there is something wrong. Finish, right? Okay. So let me just pause to find out what the error is, and then come back to you. Okay, so I'm back, and the error was really very trivial. But it takes time to, debug this kind of circuits. Sequential circuits are really too complicated because of the sequential nature. Anyway, the error was that reset hasn't been brought down to zero. So the circuit was reset the whole time. So it was stuck at the initial state for the whole time. So the only thing that I did was to set reset in the next negative edge to zero to deactivate reset. Okay. And that's it. That's basically, I don't think we need this anymore. So basically at the negative edge of the clock, we set go to 1 so that we have a positive edge on go. And then we start the calculation and then we wait for D ready to be 1. And we at the same time, we set go to 0. Okay. Setting go to 0 has the effect of going to S1 rather than S0. Okay. And here we are just checking if D out, okay, does not equal the expected GCD. Then we report an error and increment the error counts. Okay. So I just ran this and made sure that it works, but let me just show you again. First of all, let me compile. So this is GCD and TB GCD. Let's see. And also just to make sure that everything is fine, let me rerun the golden file generator. Okay. So 1,000 test vectors has been generated. Now you can just, I think I didn't comment out the portion for, I don't need the value them. I needed it for just for debugging the VCD file, no longer needed. If you need it, of course, if you need to do debugging, and by all means, you need to look at the waveform, okay? So let me recompile because I just changed the source code and then run the a.out. Clearly, I clearly need this waiting for negative edge here, okay? This is the one that changed when let me recompile and run. All outputs matched the expected result, which is a success, okay? So I'm going to upload these files to the same location as before that contained the multiplexer. Hopefully that you guys do them yourself. I mean, try to code them yourself because I'm going to assign or give you an assignment on Verilog that is going to be automatically graded. Okay. I will prepare comprehensive test bench to test your modules. Okay. And you'll be submitting to GradeScope and it will be graded automatically. So yeah, I mean, you should take advantage of that as a practice on Verilog. Thank you for watching. See you soon.